Hello viewers, we are back with another video. I hope you are doing good. Today we are going to take another question from line 75 series. This is Leetcode 141 linked list cycles. We have to detect the cycle in a linked list. So for an example here, we'll be given a list, and always whenever a linked list will be given, we'll be given the head of the list, the first node of the list. And we need to find out if there is a cycle. What is meant by cycle? So if linked list points back to one of its node, like say we have some nodes here. The last node is pointing back to one of the node. So if we'll try to visit, we'll visit from 3 to 2, then we'll go from 2 to 0, from 0 to -4. From -4, we are again back with 2. We already have visited 2. We are going back to 2 again. From 2, we'll go back to 2, 0, 4, -4, and this will keep on continuing if we'll try to traverse normally. So this is the uh, cycle where if we have visited some node, we are visiting it again. That means there is a cycle in the linked list. How we can find out? So the very brute force approach would be like what we do in arrays. We can traverse the array one by one. We'll get the value one by one, right? That's what we do there. And then we'll try to keep the values in a set. If we are seeing a number which have already occurred before, and I'm putting it again in the set. So before putting it in the set, we'll try to check whether it is already there. If it is already there, set will tell us, okay, this is already there. That means this number is a duplicate number. That's what we do in arrays, right? Similarly, here, if we are traversing the linked list, we'll keep the values in the set. And if let's say I'm going to visit a value, I'm visiting a value, and that value is already there in the set, has set. So that means it's a duplicate value. And we can tell, okay, this there is a cycle in the linked list. But this approach will cost us O of n space complexity because we are keeping at max, we have to keep every node into the set, right? If we have to do that, O of n space will be needed. So definitely it's not a very good approach, and interviewer might not be happy with this. And so we have to think something better. So there is another approach which is very popular, which we call as hare and tortoise algorithm. It is also known as Floyd hare tortoise algorithm, I believe. So what does it say? It says that if there is a cycle in a linked list and we try to have two pointers, so that's why the name is hare and tortoise. So one of the pointer will be moving slowly, one of the pointer will be moving fast, double than the speed of the slow pointer. Fast will be moving double the speed of a slow pointer. For an example here, if my slow pointer is here, fast will start from here, the next, and then fast will be moving two steps at once. Instead of moving one step, taking one step, it will be taking two steps. But slow will be moving one step at a time. Slow will go to this, then it will go to this, then this will go to this. But fast can either start from the first node or the second node. But whenever it will be moving forward, it will be moving plus, like it will not be going to next. It will be going to next pointer. So what happens according to algorithm? It says that if there is a cycle, then this slow and fast pointer will meet at a point. But if there is not a cycle, then they will not meet and will just end our traversal. So in this case, fast will come here. So since fast has reached at the end of the linked list, will just stop, will not go further. And we can see that fast will be here and slow will be here. By the time fast will go to the end, slow will be on the second node. That means they are not meeting and there is no cycle in it. But if we take another example, let's create a cycle. Oh, sorry, I missed this part. This was already having a cycle. So fast will come here and meet the slow. So basically they are going to meet. So fast will go to second node and slow is already there. So they are basically meeting at that position. So that means it's a cycle. So now I'll explain in detail like what happens. So let's create a cycle. So let's say there are some nodes here, I'm not keeping the values, but we'll start the slow from here and fast from here, right? And this is the cycle. This is basically the cycle, and cycle length is 1, 2, 3, 4, 5. 5 is the cycle length, right? Now slow is here and fast is here. So fast will move to this position and slow will move to this position in the next iteration. So they have basically now, earlier they had the gap of 1 unit because they were just starting. They had the gap of 1 unit, and you can see that fast was already on the cycle because this is the starting node of the cycle. Now in cycle they will be meeting because cycle they will be keep on moving in the cycle again and again infinitely, right? One there will be a point that they will be meeting again. What will be that point? So if we observe what is the speed difference, so the speed difference is, if speed of fast is 2, the speed of slow is 1, so difference is of 1 unit. Whatever is the speed unit doesn't matter, but the difference is 1, whether it's kilometer per second, whatever it is, right? So, and we, if they have to meet in this cycle, they have to literally cover the distance between them. And distance is 1, 2, 3, 4, 5. And in the cycle, right? So 5 is the distance and 1 is the speed difference between them. So this is how we'll be getting the number of iterations. So this is distance, this is speed, this is basically the time. So how many iteration, how many cycles will be needed so that they will be meeting, because they have to, they have this, they are this distance apart, they are this distance apart. Now if they have to meet, because they will be traveling in the cycle continuously, right? Initially they are at max, we are assuming that they are 5 distance apart, like all they have to cover the whole cycle. If they have to cover the whole cycle, they will need this much of time, that is like 5 length, whatever is the cycle length. So whatever is the cycle length, that will be the iterations will be needed for them to meet in this, right? We'll see that in the action as well. So for an example, F is here now and S is here now. Now next time F will go to this position and S will go here. Now F will go to this position and S is already there. So they have met at this position. So we can see that they met at this position. According to our example here, we are seeing that they are meeting them. Definitely they will meet them because they have a finite distance to cover and they have a speed difference. So they are moving in a circle, so definitely they are going to meet, and this is what the time will be taken. So the time taken to meet in the cycle would be O of k, if k is the length of the cycle, plus the time will be needed to cover the non-cycle part. If I am considering non-cycle part as capital N, that time the total time taken would be O of k plus O of n. Time taken to travel the cycle length, time taken to travel the linear length. Total time would be O of n if n is the total nodes in the circle. Sorry, total nodes in the linked list. And what is the time complexity here? Time complex, oh sorry, not the time complexity, the space complexity would be O of 1, because we are not taking any extra space. We are just taking 2 pointers. So if we are just taking 2 pointers, it would be O of 1. And in my earlier approach, we were using a set. Set takes a finite length of n, right? Because we have to keep n length linked list in that n values. So that's what the space complexity for that approach would have been O of n. But here it is O of 1. So this is better than that. So let's code this up and see how it works. So we'll create 2 pointers, slow, and we'll be giving head value to it because it has to start. So it has to start from head. Fast will be head of next. And there might be an edge case to cover that this head itself is null. If it is null, then we can return this head. We don't have to do anything. So now slow is at head and fast is at the next position. Now we will be traversing. Since we have fast will be moving forward, so we have to check for the fast values. And if the fast pointer reaches at the end, then we will stop. So slow will be moving 1 point at once, and fast will be moving two positions at once. Now, if sometime my slow becomes equal to fast, that means we have a cycle. So we can return true. If that's not the case, we can just return false from here and done. This is the code is very simple. Let's run it and see if it is working for the given test cases, and this is working. Let's submit it and see if this works for all the test cases. And looks like this is not working for a particular case where input is empty. So maybe we have to check. We have already, oh, we have returned head here instead. Since it's an empty linked list, so we should return false, because an empty linked list can never have cycle. So now if we try to submit it, it should work. Yeah, now it is working fine. So I hope you would have understood the solution and you have liked the video. Please hit the like button. If you have not subscribed to my channel, please subscribe to it, because a lot of new content is coming and you'll not miss out on it. And there will be a lot more coming on UI side as well. I'll be creating a new playlist for machine coding questions as well. But yeah, so keep listening and keep subscribed. See you in the next video. Till then, bye.